This is a video on finding the surface area of a solid that's formed by revolving a curve about the x-axis. The question states, find the area of the surface formed by revolving the graph of y equals 1 minus x squared on the interval from 0 to 1 about the x-axis. My first step is to graph it. And when I graph it, I get a parabola, y equals 1 minus x squared, and I've highlighted between 0 and 1. And now I'm going to draw a little cross-section, as so, on the curve. I'm going to revolve that cross-section around the x-axis. So what I'm going to do is I'm going to draw the piece, that cross-section, reflected across the x-axis first, as so. Then what I'm going to do is I'm going to take the two right-hand endpoints and I'm going to connect them with an oval, and I'm going to do the same thing with the two left-hand endpoints and connect that with an oval, as so, and I get a frustum. And the area of a frustum is 2 times pi times the radius times the length. Now the radius is the distance from the axis of rotation to the cross-section, and that's the y-coordinate of this point. And y is 1 minus x squared, so there's our radius. For the length, I take the derivative of our y equals 1 minus x squared function, and I get negative 2x, and I square that, and I get 4x squared. So my length is, remember, the square root of 1 plus the derivative squared. Our next step is to integrate over the area to get the volume. So I have the volume is equal to, and the area has a 2 pi, so there's my 2 pi, times r, and r is right here, and then times the length, and here is my length piece. We're going to go from 0 to 1 because we're integrating over the interval from 0 to 1. And when I do that, I used a calculator, and what I got was about 5.48. And I'm done with the problem.